Hello, welcome back to Math 7 with Mr. Passon. Today we are continuing our unit on inequalities, and we're going to start solving some inequalities. And what we want to do is we want to use the exact same tools that we used for solving equations. Remember that if an equation is true, we can add the same number to both sides, and then that new equation is still going to be true, or have the same answers. So let's go ahead, and basically we're going to treat every problem. We're going to sort of pretend like it's an equal sign. So inequalities can be solved just like an equation, but with a few exceptions. Alright? So we're going to isolate the variable. Remember, that's getting the variable by itself by using inverse operations. And inverse is sort of the opposite. So when we say if we have an addition or a positive number, then the opposite is to somehow use a subtraction or a negative number. If we have a multiplication, we'll use a division. The inequality must remain balanced. That means we must do the same thing to both sides. And when you multiply or divide by a negative number, the inequality sign is flipped or reversed. Alright? Let's take an example of that to start with. So if I wrote an equation here, and I'm just going to use one with numbers that make sense. So let's take a statement that is true. 1 is less than 7. Everyone can believe that's true. Let's multiply everything by a negative 1. So we get negative 1, and we get negative 7. Well, in this case, negative 1 is actually bigger than negative 7. So when we flip everything to its opposite, a less than becomes a greater than becomes a less than. So again, remember that you can always check with real numbers that you know work and see what is going to be true and use that rule. So here we've got an n plus 5 is less than or equal to 16. We want to isolate that n, which means we need to get rid of that plus 5, which means we need to subtract 5. So what I am going to do is write minus 5 here. But to keep it balanced, I also have to do minus 5 on this side. That's going to give us n. And here we're going to use that computer notation, less than or equal to 11. Alright? Let's just check. So one of the answers that we can check is like 10. 10 plus 5. Oh, why did it give me a capital N? I wanted a lowercase n. Alright. So, we could try 10.5. Let's let n equal 10.5. And then 10.5 plus 5 is less than or equal to 16, and that is 15.5 is less than or equal to 16, which is a true statement. Good. So it looks like we should have a dot here at 11. So let's make one of these 11. So let's start with, say, we'll put 10 here. Put 11 here. 12 here. Alright. Then we can use our arrow tool to draw. And I'm going to make that a bolder arrow, so it's bigger and easier to see. I'm also going to change the color. Where's my color? There's my color. So it's a little easier to see. And then I also want that dot at the end, so I'm going to insert a shape. And I want that shape to also be filled in that same color. So I'm going to make that like that. So there is our answer. Let's go ahead and take a look at this one. We've got c minus 8, so we want to get rid of that minus 8. The opposite of subtracting 8 is adding 8, or the opposite of a negative 8 is an adding 8. But again, it needs to be balanced, so we need to do it to both sides. And we're thinking about this inequality. That's our balance point. That's exactly where our equals would go. So we get c And again, we are getting that thing where it's capitalizing. So C is greater than 22. C is greater than 22. Let's try, and again, I always want to try a number relatively close to my answer, so I'm going to try 22.1, just a little bit bigger, and let's see if that works. 22.1 minus 8 is what is that? 22 minus 8 is 14, so we get 14.1, which is greater than 14. Alright? Now this one, we want just the inequality part, so instead of a full circle, we're actually only going to do a open circle. So here, we're opening it up, and I'm going to switch the arrow to point the other way. We're going to make this point here 22. So let's say this is 20, 22, 24. And this time, again, we still want a shape, but we want a hollow shape this time. So we get one that looks like that. All right. And I took the time to make the outside color red. Not necessary, but handy for, making things look a little prettier. Here we've got a multiplication. So how are we going to get, and we can visualize this one, as that is the same as 12 times g is less than 48. Well, how are we going to get rid of a multiply by 12? Well, let's divide both sides by 12. And so then we're going to get g is less than 4. And it's auto-capitalizing for me, so I'm just going to put a little single quote here, so that way it does not capitalize for me. So we need g is less than 4. That means we need an open dot, just like we have here. We need to decide where 4 is going to be. So let's make this 1, 2, 3, 4. Oh. And then we need g values less than 4, so we need an arrow pointing down. And there we go. Again, you can check your answer, so let's pick a number like 0. 0 is less than 4. 0 times 12 is 0, which is less than 48. So we can check it and see that it works. Here we've got a division. So we've got p divided by 3 is greater than 9. Alright? Well, how do we get rid of a divide by 3? The opposite of dividing by 3 is multiplying by 3. So we have p divided by 3, all times 3, and that should be greater than 9 times 3. So that's just going to be our p is greater than 27. Let's try a number, so let's go ahead and do 28. Or maybe say p equals 30. Alright, now we've got 30 divided by 3 is greater than 9. Yes, that's true, because 30 divided by 3 is 10. So 10 is greater than 9. So that works out. Here, again, we want a hollow one. So we're going to take this one, copy it, put it on our value that's going to be our 27. And we want the values bigger than that one, so we want the arrow pointing up. So we're going to grab that arrow there. And then we just have to write in that that is the value that's 27. So we could make this one 26, 27, 28, 29, and keep going. Now we're going to have to deal with the inequalities where something flips. So inequalities sometimes involve negatives. Negative numbers. Remember, when multiplying or dividing by a negative, be sure to flip the inequality. Alright? So here we're going to divide both sides. By negative 4. And so then we're going to get k, instead of being less than or equal to, is going to be greater than or equal to whatever 22 divided by negative 4 is, which is negative 5.5. Alright? Now I'm going to flip back so I can get a copy of some of my arrows. The idea being that I will use these to fill in the ones as we go along. So for this one, it is a greater than or, again capitalized on me. We want k is greater than or equal to, so we want a solid one. We want it halfway between 5 and 6, and then we want numbers that are bigger than that. So we're going to pull this one over here, and then so I can say this is negative 6, this is negative 5, and then negative 5.5 is halfway in between, and then this is negative 4. Here we've got a divide by 2, so we're going to multiply. Sorry, divide by negative 2, so we're going to multiply by negative 2. And that's going to flip our inequality, so we're going to get s is less than negative 10. Alright, so there we're going to use one of these. And that's going to be negative 10, so that's pretty close. We'll move this one over here. So we need that value where we put that one to be negative 10. Oh. So that means maybe this could be negative 5 and this could be 0, and we're going by 5s. Or we could put negative 9, negative 8 there. Here, again, we're going to flip, so we're going to have x less than or equal to, because we flip our inequality, 35 divided by negative 7, which is negative 5. So we have x is less than or equal to negative 5. Now, less than or equal to means we're going to include the dot. So we're going to put a dot on, we'll say this one is negative 5, and we want the values less than. So we're going to put an arrow to the left. So this could be negative 6. Sorry, negative 6. Negative 5. Negative 4. With this one, we're adding 16 to both sides. So let's just go ahead and put a plus 16 and a plus 16, and then we get x is less than, and again it capitalized on me. When did they change this feature? 27. So we want an open dot there on our 27. So we're going to pick one of these values to be 27. I'm going to say this one here. And we need the down arrow. I suppose I could have copied both of them at the same time. Alright. We want to get rid of this plus 10, so we have to subtract 10. It's not multiplying or dividing by a negative though, so everything stays the same. So let's go ahead and put our minus 10 and our minus 10, and we get 2 is greater than or equal to x. Oh, sorry. 8 minus 10 is negative 2. Now, we could also write that as x is less than or equal to negative 2. Okay? And then that means we need a solid circle. And we need an arrow going down. Now we need this particular value to be negative 2. So this would be like negative 1 and 0. And I'm going to move that one just a little bit further over so it touches, because I really like that arrow connected to the dot. Here we're multiplying both sides by 8, so it's not going to flip the inequality. Remember, it's only when the number that you are multiplying or dividing both sides by is negative. So we have x is greater than negative 24. Let's say this value here is 24, and then we want an arrow to the right. And there we are. This one, again, we're dividing by a positive number, so nothing changes, so it's x is greater than or equal to negative 18. Let's call this one 18. Here, we need to get rid of that plus 7, so we're going to subtract 7 from both sides. And negative 15 minus 7 is going to be less than or equal to x. So that's negative 22 is less than or equal to x, which is the same as x is greater than or equal to negative 22. So again, we can make this negative 24, negative 23, negative 22. And you can keep going. Alright, so that's what we're doing today. Again, solving one-steps and inequalities. The only difference is that we need to flip the inequality when we multiply both sides by a negative or when we divide both sides by a negative. Other than that, everything else is the same.